In today's class, we're going to discuss about non-deterministic finite automata. In the non-deterministic finite automata, is discussing about what are the tuples and how the sum comes and what is the difference between NFA and DFA. How the example is solved here. We're going to discuss in myself, SHARMILA. We're going to discuss about non-deterministic finite automata. Here about non-deterministic finite automata is discussing about the tuples. What is the difference between NFA and DFA? In that NFA and DFA, what we are discussing is here is every state of DFA always has exactly one existing transition arrow for each row in the C alphabet. So only one exactly transition from one state to another state, that is DFA. But in the non-deterministic finite automata, a state has many, that is one or more or zero existing arrow of each alphabet symbol. The example given here is from Q1 it goes to Q0 when it's a Q1, then Q1 1 if you give it goes to Q1. So one transition, one state. But here in the Q1, if you see the non-deterministic automata, in the Q1 for one input it goes to Q1 itself and it goes to Q2. So it is 0, 1 or more existent arrow. In DFA label on the transition arrow or the symbol from the alphabet set sigma. But in the NFA label, the transition arrow symbol from the alphabet or epsilon, 0, 1 or more arrows are to be formed. And then we have given that difference between the Y NFA. DFA is faster, but NFA is slower. Why DFA is faster? If follows only one path, that's why it's a faster. But in the NFA it's slower because it choose between many paths. But in the DFA it's complex, more number of states and transition. But in that NFA it's simple. So the example given here is one will be in the third position from the end, and the second position one will be at the end. So here the NFA is, if you see the difference between DFA and NFA, one only one transition, but in NFA more than one transition occurs for the one input. So in the Q1, if you see one, it goes to Q1. If you see one, it goes to Q2. There is a two transition, one or more or zero transition occur in the NFA. In that NFA, there is a five tuples Q, sigma, del, Q naught, F. Before going to NFA, we're going to discuss about what is a DFA transition. So Q is a finite set called the states. Sigma is a finite set of alphabets. Q is a transition function. It goes to exactly one state. Q naught is your initial state. F is your final state. So here in the NFA, the transitions are Q is a finite set and sigma is a finite set of alphabet. Del is a transition. One or more or zero states may occur. Q naught is a start state and F is your final set of acceptance state. Here every non-deterministic finite automata has an equivalent deterministic finite automata, and every DFA is a default NFA. Here, the example given for the NFA, the example is given as a diagrammatic format. The transition diagram Q sigma del Q F naught. We're going to find out. Q is a finite set of state, as I said. Q is Q1 state, Q2 state, Q3 state, and Q4 state. Sigma is 0 and 1. The transition occurs here is 0, 1, and del is a transition from one state to another state when its input is 0, when input is 1, when input is sigma. We'll see one example for the state Q1. If you give input 0, it goes to the self state Q1. If you give Q1 1 input means it's go to Q1 comma Q2. So two states. If you give epsilon, it goes to null. So that's why representation is here null. And then the start state is Q1 because the starting arrow is represented here. So Q1 is the start state, and double circled is Q4. So double circle means this is the final state. So Q4 is your final state. So in today's video, we have discussed about what is deterministic automata and what is the difference between DFA and NFA, and what is NFA, what are the five tuples. With one example, we have discussed. We'll meet in this next video. Thank you.